Welcome back to the .NET Way. You're watching episode 20 of our .NET Core interview series. Because this is a milestone episode, we are doing something special. We are going deep into a massive 20-question masterclass on something every senior developer must master: design patterns. Let's ask our senior developer Aarohi which patterns she uses in real-world .NET Core enterprise projects and how they actually improve her code. Welcome, Aarohi.
Thank you. It's a big topic today, but I'm excited to dive in.
Aarohi, let's start with the fundamentals. Why do developers care so much about design patterns?
Design patterns provide proven, standardized solutions to common architectural problems. They drastically improve code reusability, testability, and maintainability. Instead of reinventing the wheel for every application or service, we apply these battle-tested solutions because we already understand their trade-offs and benefits.
Let's talk about one of the most heavily used ones, the repository pattern. Where do you use it?
The repository pattern is essential for abstracting data access logic. Instead of tightly coupling our services to entity framework, I use an interface. By creating an iProduct repository interface, as seen here, it makes mocking data for unit testing incredibly easy and allows us to swap the persistence implementation if business requirements change.
What is the difference between the repository and unit of work patterns? Do you use them together?
Yes, they complement each other perfectly. A repository handles data operations for one specific entity. A unit of work coordinates transactions across multiple repositories. In complex domains, I use iUnitOfWork.save changes asynchronously to ensure all changes across multiple tables are committed in a single, safe database transaction.
How do you implement the Singleton pattern in real .NET Core apps?
The Singleton pattern ensures a class has only one instance during the entire application lifetime. Instead of writing complex custom singleton classes, we just register the service using add singleton in the dependency injection container. It's perfect for stateless services or shared in-memory caches.
What is the factory pattern? Show us a real-world example.
The factory pattern creates objects without exposing the complex creation logic to the client. Looking at this snippet, depending on the string passed into the method, the factory uses a C# switch expression to instantiate and return the correct processor, like PayPal or Stripe, while keeping the controller completely unaware of the setup logic.
Have you used the strategy pattern? What's a good use case?
Yes, it's great for encapsulating algorithms. I use it for applying different discount rules. Instead of writing massive if-else blocks for every discount type, we inject a specific strategy, like holiday discount. We just call apply function. This makes the code highly flexible and perfectly follows the open-closed principle.
How does the Mediator pattern work with CQRS in .NET?
The Mediator pattern acts as a central hub for communication. With the Mediator library, I implement CQRS by separating commands and queries. The API controller just sends a create order command, and Mediator routes it directly to this specific handler. It completely decouples our API from our business logic.
Where would you apply the Decorator pattern?
The Decorator pattern lets you attach new behaviors dynamically without changing the original code. In this DI setup, I have a standard email service. Using services.decorate from libraries like Screwtor, I wrap it inside a logging email service. I can now add logging or retries to my emails without ever modifying the original email logic.
Have you ever adapted third-party APIs using the adapter pattern?
Yes, the adapter pattern is a bridge between two incompatible interfaces. When integrating an old XML-based banking service into our modern JSON system, I wrote an adapter class. Our app talks to the adapter in JSON, and the adapter translates it to XML for the legacy system.
What is a highly underrated pattern in your opinion?
The null object pattern. Instead of returning null and forcing the consumer to write null checks, I return a no-op object or an empty collection, as shown here. It avoids dreaded null reference exceptions and simplifies code flow.
Let's talk about constructing complex objects. Have you used the builder pattern?
Absolutely. The builder pattern separates the construction of a complex object from its representation. In .NET Core, we see this everywhere with Fluent APIs. Instead of a constructor with 15 parameters, we chain methods together like this. It makes the code incredibly readable and ensures the object is built in a valid state, step by step.
Where is the chain of responsibility pattern hiding inside .NET Core?
It's the backbone of ASP.NET Core middleware. In this pattern, a request passes through a chain of handlers. As you see here, each middleware piece decides whether to process the request and then calls next.invoke to pass it to the next link in the chain.
How do you handle configuration? I hear the options pattern is very popular in .NET Core.
Yes, the options pattern strongly types your app settings.json configurations. Instead of injecting iConfiguration and searching for strings, we map the JSON to a C# class like payment settings. We then inject iOptions into our services. It gives us type safety and validation at startup.
What if a system is becoming too complex for a client to call? Do you use the facade pattern?
Exactly. The facade pattern provides a simplified interface to a complex subsystem. If placing an order requires calling the inventory, payment, and notification services, I don't force the UI to call all three. I create a checkout facade that handles the heavy lifting, giving the client one simple method to call.
What is the proxy pattern and how is it used for performance?
A proxy acts as a surrogate or placeholder for another object. A great use case is a caching proxy. Here, the client thinks it's talking to the database, but the proxy intercepts the call. It checks the Redis cache first and only calls the real database if the data isn't there, saving massive amounts of processing time.
How do you implement the observer pattern in modern .NET?
The observer pattern defines a one-to-many relationship where objects are notified of state changes. While we traditionally used C# events, in modern distributed apps we use a pub/sub message bus. When an order is created, the system publishes an event. Multiple background services observe or subscribe to this event and react to it independently, keeping the architecture highly decoupled.
What happens when third-party microservices go down? Have you used the circuit breaker pattern?
This is crucial for cloud-native apps. The circuit breaker pattern stops an application from repeatedly trying to execute an operation that's likely to fail. Using the poly library in .NET, as shown in this code, if an external API fails 3 times in a row, the circuit breaks. It blocks traffic for 30 seconds to give the API time to recover, preventing cascading failures.
How do you manage complex object states like an order's lifecycle without giant switch statements?
I use the state pattern. It allows an object to alter its behavior when its internal state changes. Instead of checking if status equals shipped, we create separate classes for pending state, shipped state, and cancelled state. Each class implements iOrder state and knows exactly what rules apply to that specific state.
What about the template method pattern? Where does that fit in?
The template method pattern defines the skeleton of an algorithm in a base class, but lets subclasses override specific steps. For example, if I'm exporting reports, the base class controls the overall step-by-step process. But I can create a PDF exporter or CSV exporter that overrides only the format data step, keeping the core logic safe from duplication.
Final question, Aarohi, and it's an advanced one. In a microservices architecture, if you can't use a traditional unit of work across multiple services, what pattern would you use?
In that scenario, I would use the Saga pattern. In a microservices architecture, each service owns its own database, so we can't rely on a single ACID transaction across multiple services. Instead, a Saga coordinates a sequence of local transactions. For example, suppose an order service creates an order and the payment service successfully processes the payment. If the inventory service later fails to reserve stock, the Saga triggers a compensating transaction to refund the payment and cancel the order. Rather than using a distributed transaction, the Saga pattern maintains eventual consistency across the entire system, making it one of the most important patterns for modern cloud-native applications.
Wow, Aarohi, that was an absolute masterclass. From basic repository pattern to advanced Saga pattern for distributed microservices, you've just provided an incredible roadmap for designing scalable and maintainable .NET Core applications. Design patterns are truly a developer's toolbox. If you found this 20-question deep dive valuable, hit the like button, drop a comment telling us which design pattern is your favorite, and don't forget to subscribe to the .NET Way for more .NET interview preparation and architecture tutorials. And if you'd like to learn these design patterns in much greater detail with practical examples and real-world implementations, we've created a dedicated design patterns playlist just for you. Be sure to check out that playlist after this video to deepen your understanding and strengthen your .NET architecture skills. In episode 21, we'll switch gears and explore Dockerizing .NET Core applications, from writing a Docker file to building and running containers. Thanks for watching, and we'll see you in the next one.